Hi everyone, welcome to this lesson on properties of logarithms. First of all, for your notebook, we're going to start with a formula. It's called the change of base formula. We're literally just changing the base of our logarithm, and this is in order to evaluate the logarithmic value in our calculators, because our calculators only allow us to evaluate logs with a base of 10 or a base of e. In the first instance here, if we want to have our logarithm with a base of b, but it's originally written as log base a of x, the change of base formula allows me to rewrite this as log base b of x divided by log base b of a. So you've just rewritten this logarithm and changed it to a base of b. Okay, similarly, if we want to rewrite a log with a base of 10, and just a reminder, log base 10, we just write it as log. So in this case, if I start with log base a, remember a just represents any number, x represents any positive number. If I want to rewrite this logarithm with a base 10, I can do so using the change of base formula by rewriting it as log base 10 of x on top divided by log base 10 of a on the bottom. We can also do this with natural log. If I want to rewrite any logarithm, log base a, some number, of x, some number, if I want to rewrite that logarithm with a natural base of e, I can do so by writing log base e, or natural log, of x divided by log base e, or natural log, of a. So that's your change of base formula. Let's see a problem. First example. Suppose we want to evaluate log base 4 of 25. Well, we previously learned that we would answer this question by asking ourselves, 4 to what power gives us 25? Well, that's an odd question to ask because that's not an integer power. So it's kind of funky to figure out without a calculator. And so now we're going to use the change of base formula to get this value right here. Changing this to, let's do a log base 10, I can rewrite this as log of 25 divided by log of 4. Why is it helpful to change our bases to either a log base 10 or a natural log? Because our calculators actually have the capability of calculating these for us. So now that I've just rewritten this using the change of base formula, I can go ahead and get these values in my calculator. So if you look for the button log on your calculator, that approximately, so I'll change this to an approximation sign, it's not exact, but you get approximately 1.3979. And then in your graphing calculator, if you type in log base 10, so just log of 4, we get 0.062. And then just simply doing that division on your calculator and dividing those in our calculator, we get approximately 2.32. So 4 to the power of 2.32 gives us roughly 25. Okay, we could also use the change of base formula here using the natural log. So I can rewrite this as the natural log of 25 divided by the natural log of 4. Again, using your graphing calculator, you can type in, find that button that says ln, natural log of 25, natural log of 4, and divide, and you will arrive at the same answer here. So this is how the change of base formula is helpful when evaluating a logarithm. All right, now let's look at some properties of logarithms. First of all, we have what we call the product property. Okay, so here's the general product property. If you have log base anything of some number times another number, we can split those up and expand the logarithm is what we say. We can expand the logarithm by addition. So whenever you have the product of two things inside a logarithm, you could go ahead and split that up into log base a of u plus log base a of v. Okay, similarly with the natural log, the same property holds true. Okay, the next property is the quotient property. It's really the same thing, but when we're dividing two numbers in a logarithm with any base, a, we can split those up, or what we say, expand the logarithm into subtraction. So we have log base a of u minus log base a of v. And then the same thing holds true for natural logs. We also have what we call the power property. This one's pretty simple. If you have log base a of some number to a power, that power can actually be brought down in front as a leading coefficient there. So log base a of u to the power of n can be rewritten as n multiplied by log base a of u. So let's see a couple examples. In this example, we're going to write the logarithm in terms of the natural log of 2 and the natural log of 3. So let's see what we're given here. First, I have the natural log of 6, and we're trying to rewrite this using the properties of logs in terms of the natural log of 2 and the natural log of 3. Well, first of all, 6 is equal to 2 times 3. So I can rewrite this logarithm as the natural log of 2 times 3. Once it's written as a product of two numbers, I can go ahead and expand that using the product property into addition as the natural log of 2 plus the natural log of 3. So that's the first example, part A of example 2. Next, we have the natural log of 2 divided by 27. So let's go ahead and first use that quotient property and rewrite the division of those two things by expanding this into the natural log of 2 minus the natural log of 27. But I want to rewrite this in terms of the natural log of 2, which I have here, and the natural log of 3, which I don't quite have. But I could rewrite the number 27 in terms of the number 3. It equals 3 cubed. So from here we have the natural log of 2 minus the natural log of 3 cubed. We're getting close. Now using that power rule, how could I rewrite the natural log of 3 cubed? Well, I can go ahead and bring that power of 3 down front and make that a coefficient. So our final answer would be the natural log of 2 minus 3 times the natural log of 3. So now you've rewritten this problem in terms of the natural log of 2 and the natural log of 3. In this example, we want to find the exact value, but we don't want to use our calculators. So we have to depend on the properties of logarithms to do this here. So first and foremost, I'm going to go ahead and look at log base 5 of the cube root of 5 and think about how I could rewrite this to evaluate it and get an actual value. Well, we know the cube root of 5 can be rewritten as 5 to the 1/3. So let's just rewrite this logarithm as log base 5 of 5 to the 1/3 power. Okay, now using one of our properties we just learned, the power property, we can take that exponent of 1/3 and we can write that as a coefficient. So now using that rule, we have 1/3 times log base 5 of 5. Well, this is really easy to evaluate. You're simply asking yourself, 5 to the power of what number equals 5? Well, that's easy. It's just 1. So that logarithm literally just equals 1. So I'm going to go ahead and rewrite this now as 1/3 times 1. And what is 1/3 times 1? It's just 1/3. So that exact value, without using a calculator, we just figured out is 1/3. Okay, let's look at b. The natural log of e to the 6th minus the natural log of e squared. Okay, well, I know here using my properties of logarithms that I'm subtracting two logs with the same base. They're both natural logs, so they both have a base of e. And when I'm subtracting, I can go ahead and condense those together and rewrite them as a quotient using the quotient property. So now I have the natural log of e to the 6th divided by e squared. Now we're going to go ahead and just use some basic properties of division from Algebra 1. What do you do when you're dividing numbers of the same base with the exponent? Well, you subtract the exponent. So what's 6 minus 2? That's 4. So together, this equals the natural log of e to the 4th power. Now all we have to do is find the value. The natural log is log base e, right? So let's rewrite this as log base e of e to the 4th value. How do you evaluate this logarithm? You simply ask yourself, e to what power equals e to the 4th? So e to what power equals e to the 4th? Well, that's easy. It's just 4. So the exact value here without using a calculator is 4. Another way to go ahead and address this problem is from this point, we can use the power rule and rewrite this as 4 times the natural log of e. And remember one of your basic properties, the natural log of e just equals 1. So you're left with 4 times 1, or just 4. All right, in this next example, we're going to expand the logarithmic expression, which is currently condensed as either a product or a quotient, and we have to use a combination of those properties to expand the logarithm here. So first and foremost, I see that this is a product. I have 5 times x cubed times y. I actually have 3 terms there that we're going to be using the product rule to split up this logarithmic expression. So I'm going to take log base 4 of my first term, which is 5, and add that to log base 4 of my second term that's in the product, which is x cubed, and add that to log base 4 of my third term in the product, which is y. Now the only other thing that you could do here is take this exponent of 3 using the power rule. We can bring that out front. So using that power property, my final answer would be log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. So that would be the expanded logarithmic expression there. Now let's look at b. We have the natural log of the square root of 3x minus 5, which, keep in mind, I could rewrite that as 3x minus 5 to the 1/2 power. That means the same thing. So we're dividing here, which means I'm going to use that quotient property. So I'll rewrite this as the natural log of 3x minus 5 to the 1/2 power minus, we're using subtraction when we use the quotient property, the natural log of 7. Last but not least, use that power rule to bring that out as a leading coefficient. And there you have your final answer. All right, in this final example, we're going to condense the logarithmic expression given. So we have a couple things to pay attention to here. First of all, we are adding 2 logarithms with the same base, which means we can use that product property and we can condense those into a product with 1 logarithm base 2. So I'll rewrite that first, keeping this coefficient of 1/3 out front. We have 1/3 log base 2. Now take these terms and write them as a product. X multiplied by this term, x plus 1. So now we just use that product property. And last but not least, this 1/3 as a coefficient can actually be written as a power here. So we can rewrite this as log base 2 of this entire thing, x times x plus 1 all to the power of 1/3. Okay, one more thing. Let's just write that then as the cube root. So my final answer, all condensed, would be log base 2 of the cube root of x times x plus 1. And that's it. I hope you enjoyed this lesson on properties of logarithms.